Okay, now for some moron testing, and welcome back. So far we've been using things like integer values and that sort of thing, and even an occasional true or false value from Boolean. Those things, by the way, are oftentimes considered to be things called flags. A flag is something that is used as a indicator to whether a condition exists or doesn't exist. Boolean flags are true or false. Integer flags can be as simple as a 0 or 1 to mimic a Boolean flag, since effectively Booleans are stored as integers. Or they could be even more complex, knowing that anything that's not a 0 comes out as true in C++. One of the interesting things we have is something like this. Let's make an integer. There's a little number. So if we do your standard cout, like we always have to do to prompt for input, and our standard cin to get that number. This works really, really well until you put in something that's not a number, something that's a letter or whatever. So if we output what you printed, something like that, if we run this, you'll see that it works relatively well as long as you give it an integer. If you give it a double, it'll ignore the decimal point. We've seen that, so we know that input can be incorrectly interpreted based upon what we give and how we choose to store it. But what happens if somebody runs this and instead of giving a number, they give them a letter? Well, our number goes to 0. Regardless of what was stored up here originally, it zeroes things out now. So what happens with us is this breaks. Well, cin is kind of an interesting thing. It's an I/O stream, or actually it's an input stream. And an input stream comes out of the input-output stream system, has a series of flags to it. And if you look here, you'll see there are 4 values or member constants. One is called good bit, one is called EOF, for end of file bit, one is called fail bit, and one is called bad bit. And this tells you the good bit says that we didn't get any errors. The end of file bit says, well, I reached the end of file operator or symbol on the end of an input operation. The fail bit says, well, I have a logical error. Something didn't quite work right. And the bad bit says I had a read-write error. And they give us functions in the I/O stream to actually check to see what has happened. Is it good? If there are no errors, it's true. These guys will all be false. So you can kind of read the flag set to see some interesting stuff. Now, note that the fail test will fail for both a fail bit and for a bad bit. So whether it was a logical problem or a read-write problem, it's not going to work very well. The bad bit will only fail if there was a reading-writing error on input and output. We can now use that knowledge here to say, okay, did we actually get a number? We can say if standard cin good, if it's still good, we can actually print out your number for you. And we will go down here and reformat our code to indent things correctly. So is it good? Yay, print it out. Else, input a number. 2. Hey, the number 2 works. Everybody's happy. Input a number. 2. Ah, there's an error input. So we have, in an interesting way, a Boolean flag that is called this good bit, which is a flag for us, that says we can now test to see whether our input has been good or bad. For whatever reason. We can check for bad, we can check for fail, but typically if it's good, it's good. Now, this leads to us in later chapters a way of correcting input. Right now, all we can do is punt. We can say, hey, you didn't give me something good, there's an error, I'm not going to do any processing. So if this was a real more complicated program, you would put your processing inside the test to see if you got good stuff. You got good stuff? Do it. You have bad stuff? There's no need in doing the processing. There's no need in wasting the cycles on the computer to process bad output. And you can tell people, hey, there was an error in input. You don't know what it was. You can't really specify it from this, but this gives you a way of cleaning up some of your input. You can use Boolean flags. You can use integer flags. You can use all kinds of things in code, but this is just a quick way of showing you something cool about cin that we can actually read and see what's going on a little bit. And did it actually work? If you want to, this of course is over in the C++.com reference library for iOS states. You can look up each one of the individual operations and see what it returns. There are a couple of other states that are interesting to know also. This one down here will come in handy later on. It's called clear. Clear resets the flags. So if you have bad input in your stream, if you got an A or a 2 or something like that, then this thing right here will give you the chance to, through the use of a couple other cin commands like ignore, clear out the pipeline, but reset the flags, clear the pipeline, and try again. But we don't really have that available to us at this point in time. We really can't loop through things, and you can only really do it once. So if you have a really, really slow user who tries 2 and 3 and keeps spelling numbers out, it's going to keep failing. And right now we can only do it once. So there's a quick look at Boolean flags in the cin.good, and we'll progress with some more. Hope you have a good day.